Good afternoon, everybody, and thanks for joining us. My name is Joe Flanagan. I'm the project manager for the Energy House 2 project, which is one of a number of things we're going to talk about this afternoon. So, just by way of kind of background to this, here at Salford, we've got quite a collection of facilities and laboratories, all to do with energy use in the built environment. Got some quite unique facilities, as we'll hear in due course. And it's quite an important area. This the UK as a whole, about 30% of our carbon emissions comes from heating buildings, and there's a lot of emphasis at the moment trying to reduce carbon emissions. And buildings, quite difficult to reduce carbon emissions without spending a lot of money. Got a lot of old buildings in the UK, and we're only replacing those buildings. About 1% of the stock is replaced every year. So even if tomorrow we introduce the most stringent building regulations you can think of, take us 100 years before all the buildings in the UK were of a really high standard. So we've got a lot of old energy efficient buildings, especially in this part of the world. Terraced houses which were built probably 60, 70, even 100 years ago, are still used and good houses, but very energy inefficient. So at Salford, we've got quite a lot of expertise in this area about how we can make buildings more efficient. I guess we started probably about 10 years ago with something called the Salford Energy House, which you'll be hearing about in more detail, which is basically a Victorian terraced house within an environmental chamber, which allows us to do research and test measures that you might want to use to make buildings more efficient. And the advantage is we can do these tests very quickly. We can control the temperatures, and we can do a test in a couple of weeks, which if you went out and did it actually on real houses in the field, it would probably take you a couple of years, because you'd have to do it with and without the measure, and you need a whole year of heating cycles to be able to prove the effectiveness of your measure. So started off with the Energy House, say about 10 years ago. We also have a specialist laboratory which can measure the thermal characteristics of materials to very high accuracy and standards. So that's a very specialised laboratory, but used quite frequently by outside commercial organisations. And about 3-4 years ago, we initiated the Energy House 2 project, which is what I'm managing, which is a new laboratory we're building just by the Allerton building over on that side of campus, right by the railway station. And if you go over there, you'll see that a large structure is emerging there, and that will be 2 very large environmental chambers, and we can accommodate whole houses within there. I won't talk in too much detail. We're going to cover that in a bit more detail soon. But that will be operational at the end of this year. We've had a big European Union grant to help us get this thing off the ground, and we'll talk in more detail about that later. And about a couple of years ago, we added another laboratory to our portfolio, which is the Smart Meters, Smart Homes Laboratory, which is all about how we can best use a lot of these smart technologies, Internet of Things, to actually use energy more efficiently within the home. So that's taking advantage of different tariffs, switching things off automatically, switching things on, and using technologies like heat pumps. So that's quite a new development and quite exciting. So that's a kind of brief overview of what we've got. As I say, there's big drivers around this area. I mean, the other thing I should have mentioned is that the government has declared that you no longer be able to have a gas boiler installed in your house. So we've got a wholesale switch towards electrically heating, which will be things like heat pumps and possibly hydrogen. And again, we're kind of well equipped to do research and testing in this area. So that's my kind of brief overview. I'm now, I think, going to hand over to my colleague, Nigel, who is going to take you through some of those things I've just mentioned in a bit more detail. I believe we're going to take questions towards the end. So if you have any questions, just wait until the end, and we'll have a discussion session and hopefully answer all your queries. So I'll hand over to Nigel now and let him talk through some of the detail. Thank you.
Hi everyone. So what I'm going to do is basically we've got a series of videos here, so it may take a while just to a minute or two to get them all lined up. So, so the first one is on Energy House 1. So if you just bear with me for a second.
Right. Yeah. Well, we'll see. I mean, I'm already.
Hi, my name is Dr. Richard Fitton. I run the Energy. Hi, my name is Dr. Richard Fitton.
So just bear with me. Like I'm saying, this takes a little while to do.
Well, I've got to at least get Energy House 2 out of it. Well, I'll tell you what, they're not very.
I think we are here now.
They're not very sentimental.
Can you see the picture now, everyone? Joe?
Yeah, I can see it. Yeah, I think you can go for play.
That's fine with me.
Yeah.
So this is the Energy House. So we have Victorian terrace.
Yeah, no, I mean,
Nigel, I think that, can you turn the audio up a bit? It's quite quiet.
Yeah, I've got. That's all I can do. That's as loud as it can be at the moment.
Difference about this place is it's a huge environmental chamber. So we can take the temperature down to -12, -30.
I mean,
with rain, snow, solar radiation. That allows us to carry out what's experiments where we control the climate itself. So a typical use of this would be to set control from there, standard occupancy pattern, then change the weather.
if everything's going
How we control perform spring, how we perform winter, and how we perform the autumn.
letting people get on
That
with their
allows
job,
us to
she's really good.
take very detailed and accurate measurements of performance. We can do the same with things like
Okay, I think we're all having problems on the audio there, Nigel. I mean, I can kind of talk over it if you want and interpret the words that Richard is saying. So basically, there we've got the Energy House 1, which I said we built about 10 years ago, and that's in the Cockcroft building. It's in an old laboratory. It was brick by brick from original materials, taken down the corridors and rebuilt in that facility that you see there, and it's gone now. I think Richard, that's Richard Fitton, by the way, is in the school, Dr. Richard Fitton. Richard was just saying that within that laboratory there, we can recreate weather conditions. We can go down to -12 degrees C, and we can go up to, I think, +30 degrees C. So that kind of covers UK energy conditions, and we can control the temperatures within plus or minus half a degree centigrade. And we can recreate rain, because wet buildings perform differently than dry buildings in terms of the energy. And we can recreate solar radiation to simulate solar gain. And we can also make it snow as well. So we've got a very controlled environment there for actually testing that Victorian terraced house, and then we can add all sorts of things and see what the difference is. So we might change the windows. You can see we've got very old sash windows there. And if we put in new modern double glazed units, we can monitor and measure exactly the change that's occurred as a result of those new modern windows. We can see how much energy they save, and to a very high degree of accuracy, much higher accuracy than you could if you tested those windows in the field, as it were, in a house. So I think that's probably about all we need to say about Energy House 1. Nigel, I don't know if you've anything you want to add there. Have I covered it all? Can't hear you on mute.
Yeah, I think that's about it with Energy House 1, and it finishes off there with talking about that's Energy House 1. We can do certain things with that, but what we really want to look at is Energy House 2. So hopefully what we'll see is...
Before we move on, I mean, it's worthwhile saying that we're only kind of seeing half of it there. The other half of that lab is a big control room. We've got about 500 sensors throughout that laboratory there, measuring temperature, humidity, all sorts of energy flows, and that data is all collected in real time. So we've got huge amount of data collection and data analysis capability. So
Okay,
I think now
we'll move on to Energy House 2. So can you see that now?
Not yet.
Okay, hold on, let me do the screen share, stop sharing there. Right. Just bear with me again.
Just while Nigel's queuing that up, I mean, Energy House 2, as I say, we initiated this project about 4 or 5 years ago, and we were very successful getting a big European Union grant before the doors closed. So here we go.
No, it seems to have been a few. Here we go. So I think this one has got, we've got subtitles here, so yeah, should be all right. I'll turn the music up.
So that size there is about 8 times the size of the Energy House we have at the moment, and you can see there's like two chambers side by side. We can accommodate four buildings within that. So I don't know, 2 detached houses in each side of the chamber, or you know, 2 semi-detached houses, and we can control those chambers independently. So they have a kind of view with the roof off, which wouldn't happen normally in practice. And you can see there's 2 chambers there. We've got 4 houses. But again, hundreds of monitoring points around those houses and actually in the chamber. And we've got electric vehicle charging points. In terms of the kind of capability, we can go down to -20 degrees C and up to +40. Well, there we go. And what that means is we can cover 95% of the world population. I mean, anyone would think I'd written this. So we're just getting a bit of a fly through. In terms of where we are, I mean, if anybody's been out that side of campus, you'll see that the steel structure is up, and we've got the roof on of this new lab. The thing will be weather tight probably in about 4 weeks, and they'll start the fit out with all the heating and ventilation system. But we're just procuring a lot of equipment. We've just procured the snow machine to reproduce snow, and we're actually building the rigs to simulate rain and solar radiation. And once the chamber's complete, we will wheel those in and we'll be ready to go. Yeah, so we think we might be able to use these chambers when we don't have maybe to be doing other types is important. So, you know, vehicles, got mobile homes there, just to see how they perform under different climatic conditions. So, yeah, any time of the year we could recreate snow in the middle of summer, or we can recreate the Sahara Desert in the middle of winter. And again, to incredibly high accuracy in all the data recorded.
Right, so
I don't.
Can you hear me?
I'd say no. It might be worthwhile opening. Have you got any questions at this point? I mean, we've shown you a couple of videos there. I know we've got questions at the end, but it would seem appropriate if anybody's got any burning issues, you don't quite get what we're doing there, just raise your hand and we'll answer any questions. No, it's all clear to everybody. Good.
I'll move on then. So you've seen the Energy House 1, you've seen Energy House 2. The next thing we've got is just over the road from the Peel Park campus, next to the old fire station, we have Jewel House. Now, Jewel House is where James Prescott Joule lived. He's a very eminent scientist. If you look on the back of any of your food packets, you'll see there that there's the nutritional information in kilocalories, but it's also got KJ, which is down for joule. And that's the unit of energy that James Prescott Joule, who lived in Jewel House, put his name to. So we'll have a little bit of, we'll see a little video now. Put in the text box if you can't hear it, I will talk over it. I can hear it, so I might as well just talk over it anyway. So just give us a minute.
Hi, my name's Nigel.
Getting a little bit better at this. So yeah, tell me if you can hear this or not. So I will start it now.
Hi, my name's Nigel Bamber from the University of Salford.
Yeah, we can hear that, Nigel.
And I'm going to talk to you today about the Smart Home, Smart Meters Lab. This is the campus here, and as you can see, it's readily expanding. But the Smart Meters and Smart Homes Lab is over that way. So let's go and see the Smart Home, Smart Meters Lab. Welcome to Jewel House, which is the home of the Smart Homes, Smart Meters Laboratory. Now you may think Jewel House obviously is something to do with energy, but there's actually a surprise here. This was actually where James Prescott Joule lived. So let's go inside and have a look. This is the man himself, James Prescott Joule, who lived in this house. He was the son of a brewer, and he's also done his experiments in this very house. If we walk over here, you can see a representation of some of the equipment that he used, which was then went on to form the basis of the first law of thermodynamics. And this is the smart kitchen of the Smart Homes Lab. But it's also in Jewel House. It's actually our own working kitchen as well. So we get to use it and see it in operation every day. So if you come in and have a look in here, we do monitoring here. So if you look at all these sockets here, all these red ones, these are all individually monitored. So we control the power consumption coming out of each individual socket in here. Plus we have Alexa control in here. And if we look around here as well, you can see that we have some smart sensors and interpretation on here as well. All the devices like the dishwasher and the tumble dryer here are be able to connect remotely to Wi-Fi. And if we look around here, the piece de resistance is the fridge. If you have a look, the fridge here has a camera in there. So if you're popping out to the shops and you don't know whether you've got your milk or not, you can look at it. Also being an academic fridge, there's probably lots of out-of-date food in there as well. Welcome to the Smart Homes living room. In here, everything is connected and highly monitored. The heating is on a different circuit, the lighting and the power is on a different circuit. We have here smart televisions, smart devices, again with the interpretation around. We even have, at my feet, a smart robotic vacuum cleaner. This is all monitored from our control room, the heart of smart homes, smart meters labs, which we'll see next. And this is the control room for the whole of the smart homes lab, the smart meters lab. You can see over here we have a range of smart meters with isolators. We can bring each one in online to check individual meters and their functionality. And over to the other side, we have the gas meters. And we have this controlled circuit within the building. So the living room and the kitchen are individually monitored on different circuits here. We also have other devices like the consumer access devices here, monitoring the electricity consumption and the smart meters in fine detail. And if we move over here as well, what we have connected in here, we like to try and stress the system. So we have connected as well, not only a gas boiler outside, we have a heat pump in here, so we can see the interactions of a heat pump within the smart homes. And outside, we have some solar panels and electric vehicle chargers as well. And we will look at electric vehicle chargers in a bit more detail. This is another one of our facilities. The electric vehicle will become part of everybody's home in years to come. So that here, at this test facility, we can look at taking electricity from the vehicle back into the home or into the grid, and using what impact solar panels will have as well on the charging.
So that's that. I'll just close that down. Don't know whether anyone's got any questions on that one.
So I think it's myself now, Nigel, isn't it, to talk about? Yeah. Okay. It's just worth saying maybe a few more words about the smart meters lab there. You've all heard of smart meters, I'm sure, and you know, basically what they do is they're giving a real-time output of your electricity or gas consumption, which then goes up to the cloud. So you know, the one big advantage for energy suppliers is they don't have to read your meter anymore. It's all done automatically. But that information that is gathered and can be collected can be used in all sorts of interesting ways, especially as now the UK electricity network is getting very, very complicated. A lot of wind energy on the system, which is very intermittent. And so National Grid, who have to kind of balance supply and demand, have increasing challenges. You know, if it's not windy at 5 o'clock in the afternoon on a November day, we've got a problem and we have to switch on gas-fired plants and coal-fired plants. So smart meters may in the future enable demands being managed at the kind of household level. So, you know, there may well be times of the day when if you've got batteries in your electric vehicle, you might be able to sell power back to the grid and make some money. Or you can use electricity when it's very cheap. You know, in the middle of the night, if we've got a lot of surplus wind and a lot of power, then, you know, National Grid will virtually give that power away. So there's all sorts of clever things we can do with smart meters, especially if we link them to the appliances. So I think that's kind of the relevance of this area, why it's so important for energy savings and, you know, lowering the carbon emissions from the UK. I mean, it's an area where there's a lot of innovation at the moment. So a lot of people are looking at this, developing apps, developing ways of extracting that data from the smart meters and using it for the benefit of the householders so that they lower the energy bills. And that's kind of a big part of what we're doing under the Energy House 2 project. As I said, we've had a large European Union grant, and part of that grant is that we are offering assistance to local small and medium-sized companies to develop their products. And that's not only products that traditionally you think might be energy saving in buildings, such as insulation or windows or whatever, but it's also around these smart meter areas as well. So, you know, if there's any companies you know of, or you are a company who's developing technology or services in this area, we can actually help you. And it's all free of charge at the moment because we've got this grant from the EU that's paying for our assistance and paying for the access to the laboratory. So we've got a target to work with 150 businesses over the next 12 months or so. So we're very keen to talk to anybody who's got any innovation or any ideas around this area. As I say, it's completely free of charge, so can't say better than that. So we're building up quite a knowledge and a capability of local companies who are in this space. You know, we kind of hope to become the sort of hub for innovation around low carbon buildings and technologies. So we're building a big network. We're holding lots of workshops and events, and obviously when the new Energy House 2 laboratory opens, which will be early in 2022, we're going to have a lot of you know, visits, open days, and that sort of thing. So there'll be a lot of engagement going on with local industry and business. And we're also, you know, we're attracting a lot of interest from big companies in this field that you might expect. You know, the usual names like Barratt Homes and the other house builders. We're also doing a lot of work with a company called Saint-Gobain, you probably have not heard of, but they're the world's biggest construction products manufacturer based in France. They own companies like Isover, who make insulation fibre, British Gypsum, who you might have heard of, and a company called Solar Glass, who do windows here in the UK. So yeah, we're attracting international attention with this new laboratory. So that's kind of a brief overview of what we're doing away from constructing the facility. I think, Nigel, I'm going to pass back to you now. I can't quite see my schedule here because it's disappeared.
Yeah, pass back to me. So the little brief introduction there from Joe about helping businesses. Hopefully now the audio is working on the videos, because if not, this will be a difficult one. So this is an example of a business that we helped. So they came to us with an idea. They're a new startup. They had something which basically would use the smart meter and use the data coming out of the smart meter, and the fact that you can now get electricity tariffs that are variable depending on the time of day, so they alter every half hour. And this device basically would heat up your home slightly more when the price of electricity was low and slightly less when it was more expensive. So thereby you'd save money, but with the differences in the temperature were so slight that you wouldn't personally feel that there was any difference in the temperature. But this was a new startup. How do they go about proving this? And this is
Nigel, it's worth mentioning Carolus, who we'll see on the video. When he approached us, he was a postgraduate student, not at Salford, at Manchester University. So good example here of a student entrepreneur and innovator.
Great. So yeah, just give me a couple of minutes again, and I'll line this up. And once I play it, I can't see you on the screen, so you'll have to. If Joe, you tell me you can see the screen and hear the audio as well, that would be great.
Nothing's happening yet, Nigel. Yeah, we can see Carolus. No audio. No, can't hear it. Still no audio, Nigel. Do you want me to attempt to talk over this?
I'll talk over it because I can actually I can hear the audio, so I'll talk over it.
Did you remember to press the share audio button when you shared your screen?
Ah, right. Okay. Is there a share audio button as well? This is
Just underneath it.
Right. Let me go back to you are sharing the application, share audio.
heating our
Can you hear it now?
and cheaper electrons. My name is
Yeah.
Thomas. I'm the head of
Yeah.
Scotland at Evergreen
It's not very loud, but we can just about hear it.
through today's workshop. First, let's run through the content of the session so you know what to expect of today. We'll begin with a quick introduction to Evergreen Energy, electrification of heating and transport, touching upon the problems that this may create in the future, and some of the solutions that can help us deal with these additional loads, such as smart charging using dynamic electricity tariffs. We'll then follow on with an introduction to heat pumps and go through some real-world examples from the Smart Meters Lab at Salford University, leading us to the interactive part of the session where you can play around with some numbers to reinforce the learnings of today. So, who is Evergreen Energy? Evergreen Energy was set up with an aim in helping the UK achieve its carbon ambitions. Just a quick overview of some of the things that we do. We design and install renewable heating systems using trusted tradespeople from our approved organization scheme. We're making these systems more affordable through our assignment of rights proposition. We provide support, advice, and design tools for 35% of all MCS approved organizations. We're also the makers of Homely Smart Thermostat. Smart Thermostat designed specifically for heat pumps to make them smarter by connecting them to dynamic electricity tariffs and providing remote diagnostics abilities for the installers. So why are we here today? Manchester is aiming for net zero by 2038. To achieve this, we will have to see a change in the way we heat our homes, moving from predominantly gas boilers to a combination of electric heating, including heat pumps, district heat networks, and hydrogen. In this workshop, we'll go through some of the problems associated with the electrification of heating and how a combination of smart technology and tariffs can help us overcome these, giving us cozy homes that save both carbon and cost. Few numbers to get us going. National Grid estimates that around 180,000 heat pumps are currently installed in the UK, with the potential of increasing to 12.5 million heat pumps by 2038. That is 600,000 heat pumps a year. The power generation in the future is also changing. We're looking to see an increase in renewable power generation from wind and solar, doubling in almost all National Grid scenarios. Even though heat pumps are a great way at reducing carbon, we can save nearly 2 tons of CO2 per household per year by just installing a heat pump. There are some limitations in what our current electricity infrastructure can handle. Just imagine if we were all going to install a heat pump tomorrow, meaning that 12.5 million heat pumps are being plugged in at similar times of the day. Heating is not the only load that we're trying to electrify. We have seen an increased interest in electric vehicle uptake. Add those vehicles to the mix, and we have sky-high peak demands, requiring us to build more power plants, lay more cables, and pay more for our electricity. There has to be a better way, right? It's all about smart. By using smart heat pump scheduling and smart vehicle charging, we can smooth these demands throughout the day and shift the consumption of electricity to periods of high renewables, reducing customer bills, the need for network reinforcement, and increasing the use of that green electricity. This is just an example of power generation on a windy day in December 2019. We also have electricity tariff offered by one of the electricity suppliers in the UK here on the right. We can see how during this windy day, when everyone was sleeping, the price of electricity throughout the night even turned negative, meaning that heat pumps with smart heating controls, such as Homely, were automatically turning on at these times, making money for their owners for the hot water production and heating of their homes. Not bad, right? There are, of course, days when the prices are not as favorable and you don't get paid to use electricity. But even on these days, smart technology can help us shift electricity consumption to those cheap electricity periods of the day, like this here, minimizing customer bills whilst maintaining user comfort and improving the reliability of the grid. As some of our listeners may not be aware of heat pumps just yet, we wanted to give you a brief introduction into what heat pumps actually are. Heat pumps are just a super efficient way of heating your home through the heat extracted from outside air or ground and delivered to your radiators and hot water cylinder with the help of electricity. As some of the energy is extracted from external sources, heat pumps are able to deliver around 4 units of heat for every electricity unit that they consume, 3 units of heat of which are absolutely free. In addition to reducing the overall energy used for heating, they can also reduce customer bills further when combined with variable tariffs and Homely Smart Thermostat that make sure that the heat pumps are operating during the cheapest electricity periods helping the customers soak up those green electrons. For those who like a little bit of detail about how things work, here is a pretty diagram demonstrating the reverse refrigeration cycle. It has four main components, which are the evaporator, the compressor, the condenser, and the expansion valve. Firstly, the evaporator extracts heat from the collector, which is your ground array or the outdoor unit for an air source heat pump, and transfers it to the liquid contained within the evaporator called a refrigerant. The refrigerant starts to boil once it's heated up by the energy from the collector. The gas generated then moves through the compressor, which increases the pressure, which results in an increase in the temperature. This high temperature gas then travels to the condenser, which transfers the heat to the heating system, which will be your radiators and your hot water cylinder. The final step in the process is the expansion valve, which removes the pressure of the liquid, allowing the gas to convert back to the liquid before returning back to the evaporator and repeating the cycle again. I'm guessing that by this point you had enough of the theory, so let's delve into some real-world examples from Salford University's Smart Meters Lab. At Salford University, where we're trying to show that a constant operation of a heat pump that is sometimes suggested by heat pump manufacturers might not be the most cost-efficient way to operate a heat pump if the customer can be exposed to a variable tariff. In the study, we present 20% savings whilst using homely controls and variable tariff when compared to this original scenario. Just a quick run through the scenarios. Under the original control, we assume that the house needs to be maintained at 21 degrees throughout the day and that the customer was exposed to fixed price of electricity. On the homely control scenario, we assume that the customer only wants 21 degrees in the morning when he gets up and in the evening when he gets back from work. They were also exposed to a variable tariff, which in this particular scenario was Octopus Agile. There were some limitations in our study. Testing was not performed under controlled weather conditions. To show that the results were still applicable, we decided to choose a warmer day for the original control and a much colder day for our homely controls. This is to show that even on a colder day, homely system was still able to achieve 20% savings when compared to the original controls. Here we can just see the outside temperatures, where we showed that original control outside temperatures were much higher throughout the day than the homely outside temperatures. And finally, the results. Here we can see the results of the original control scenario, where we can see the set point of the indoor temperature as 21 degrees throughout the day. The internal temperature was just shy of the 21 degrees. Outside temperature, power consumption of the heat pump, where we can see that the heat pump was turning on and off to make sure that internal temperature was kept as close to the 21 degrees as possible, and the fixed electricity price that was around 15 pence per kilowatt hour for that particular period in Manchester. With homely controls, the controls of the heat pump were slightly different. So we know already that the outside temperature for this scenario was lower than the original controls, which means that the heat pump had to operate slightly more. It also tried to avoid the peak price of electricity between 4 and 7, which means that the house needed to be overheated slightly during the day, or we can see the temperature indoors raising to 21.8 degrees. And then the heating has been turned off, and the temperature slightly dropped to 21 degrees, turning the heating back on just after the price has gone low again. For the conclusions, we have shown that with the original heating controls, the cost of heating for this particular day was £1.57. For the homely heating controls, the cost of heating was 1.26 pence. This means that there was 20% saving on a colder day using homely controls and variable tariff when compared to the original controls and a fixed tariff. Now that you've seen homely thermostat in operation, trying to avoid those electricity price peaks, we'd like you to have a go at playing around with some heating schedules. We have prepared a simplified version of what we do in the Excel sheet, where you can yourself change the heating schedule of the simulated heating system to see how much savings you could achieve by shifting the heating to the cheapest electricity periods. To access this Excel sheet, please follow the link on the screen, www.homelyenergy.com/workshop, and enter password Salford. Hope everyone had a chance to download the Excel sheet. And I would just like to walk through a couple of details on this sheet. So on the left here, you have the time of the day, the price of electricity as was observed on Octopus Agile, fixed price for this particular region, set points. So these are the temperatures that you would have wanted to achieve in the morning and in the evening. This is the heating schedule. This is what we are going to be playing around with. So once these are changed from ones to zeros, we're actually turning heating on and off in these particular half hours. The next column is the change in temperature. We can see that once the heating is turned off, the temperature drops by 0.5 degrees. When the heating is turned on, the temperature rises by 0.3 degrees. The temperature column is the actual temperature achieved internally. The cost is the calculated cost of heating in that particular half hour using Agile Octopus rates. And the fixed cost is the cost of heating using the fixed rate of electricity. Over here, we have the results. So the total cost is the total cost of heating using the Agile tariff. So it's the sum of the cost throughout the day using the Agile tariff. And the total cost fixed is the same, but with a fixed tariff. And here we can see the savings. So in this particular instance, we're saving around 5% when using Agile tariff compared to fixed tariff. What we're trying to achieve here is we're trying to get this internal temperature to the set point. So we want to be 21 degrees in the morning and in the evening. And we're also trying to avoid this price peak between 4 o'clock and 7 o'clock in the evening. So the way that we can actually do this is, first, we need to make sure that the house is warm in the morning. So we need to turn on the heating a couple more times before the morning to make sure that the 21 degrees is actually achieved. And here we can see that we've managed to do that. We also know that we can slightly overheat the house and use the house as a battery before the price peak to let the temperature drop slightly during the expensive period of the day, then be turned on after the price peak. Over here we can do this by finding the peak price of electricity between 4 and 7, turning the heating off, we can see how the internal temperature now is nowhere near the 21 degrees. But what we can do is just overheat the house slightly more during the afternoon before that price peak. So let's put more heating in. And we can see how the internal temperature just slightly drops below the 21 degrees, but then bounces right back up after the price peak has dropped, and we can start heating the house again. Under this particular scenario, we managed to achieve 37% savings by just using the Agile Octopus rate when compared to fixed tariff. You can also try to beat this 37% by trying to pick out those cheapest pockets of electricity, and that's what our thermostat would do for you. Just to make it a little bit more interesting, one of the other things that we need to consider is the changing conditions day on day. And here, even though it works for this particular day, if the outside temperature for this particular house was different on a different day, this heating schedule would not have worked. And we can do that. We can check that by changing the day from 0 to 1. We can see how now, with the same heating schedule as we had before, the internal temperatures are not actually reached, which means that we need to reschedule this heating, turning the heating on a little bit more in the morning, and again overheating the house slightly more before the evening peak. Yet again, our thermostat would take all of this into account and do this for our customers. Really hope you enjoyed today's session. Thank you very much for watching. And if you have any questions or would like to talk smart or heat pumps, give us a shout at hello@evergreenenergy.co.uk with the subject line Manchester Green Summit.
So I hope you found that interesting. I'm not saying, as Joe said, that is a graduate from Manchester University. So now we've done that. Any questions on that at all? Just have a look in the chat box. Okay, so people, yeah, fine. Okay, so what I'm going to do now is just talk. I'm not sure whether this is going to be fully on topic. So you can again put questions in there about actually starting your own business. So do people that are here, do you just want to put a yes or a no in the chat box of whether you have your own business or not? So if you do have your own business, just type yes in the chat box and let's see. Okay, nothing's come in. I'm going to assume that no one's actually set business up. Right, so I'm going to give you my experience. I ran an energy business for 7 years. You might think, oh, setting up a business is really, really difficult. In fact, yes, it is a daunting task, but it is incredibly easy. So all you need to do in the UK is go to the Companies House website. So if you just Google Companies House, you can start best thing to do is start a private limited company there. It will take you to do it online. I think it probably take about 30 to 40 minutes. So it's a really quick process. It won't cost you much. I think it's only about £40 as well to set up your own company. There's templates there for articles and things, standard articles and shareholding that you need to do. So it is, just have a chat with somebody. It's a very quick, simple and cheap process. Once you've set up your company, you do have to sort of contact back to Companies House, but that's only really on 2 occasions. So once a year, they just want to know that you still exist and you're still at the address and everything's the same. So they do something called an annual return, or as previously known, a confirmation statement. So you say that I am Nigel Bradford, this is the address of the business and I am a director of this business, and you just send that back to them. There's a small charge for that. I think it's only about £15. The other thing to do is you need to submit accounts once a year. So I would certainly recommend initially that you got an accountant, because they can really help you out. You will find a lot of stuff online that will help you as well, but I certainly found having my own account. The first accountant I got was actually based over the road from me. They were a bit old-fashioned, they weren't very good. I actually ended up with a accountant based in Salford, further down Chapel Street towards Victoria Station, and they introduced me to a online accountancy app, which was really good, called Zero. There's other ones like QuickBooks, etc. So basically it's an app on your phone. You create your invoices, put all you need to have evidence of an expense. So you just take a picture with your phone of the receipts that you've got and then upload that information in there. And with my accountant, because he dealt in that Zero app, he got that information automatically as well, and at the end of the year he just submitted the accounts. So it did, I had the accountant there. It was useful also for payroll reasons, tax reasons and pension reasons. Gave me a lot of really good advice, and I think that was costing me about £25 a month for the app and for the accountant to give me all that advice and submit my accounts at the end of the year. And I was turning over enough money. That was fine. That was the biggest expense, but that was great. That was really, really good. My business was based from home, so every time I went away from home, that was a legitimate traveling expense. So yeah, no, that's very good. I would recommend it. Do not feel daunted in the slightest about starting your own business up. And if you do want to, give me a shout. I'm sure if you've got any worries at all, I can guide you through starting up a private limited company, because I've been there myself. So that's my little talk on setting a business up. Now, it's not just, if you do start the business up, it's there is advice from other people. If you were starting a business up in the energy field, then obviously we could give you some help there, but there are other organisations within the Greater Manchester area. So I'm going to do again another little video, which is from a organisation called the Growth Hub, the Greater Manchester Growth Hub, and they will give you a huge range of assistance for free to help you start your business. So bear with me again while I set this video up. Just bear with me for a minute. It's opening up into a different window there. Can you see that now, Joe?
Yeah, we can see that. Yep, yep.
Right, hopefully that will all come through now. Tell me if you can't hear the
Oh, we can hear
audio.
it. Yeah, yeah.
Okay. So I think we're just doing a finish off now from Joe.
Yeah, well, thank you for that, Nigel. I hope that you've got a good overview there of what we're doing at the university in terms of low carbon and buildings with our Energy House Lab and Smart Meters Lab. And the fact that we are, very willing and happy to engage with small companies and help you along that journey to develop products. And, at the moment, we can do that free of charge because we've got some grant aid to do it. And I think the growth hub that Nigel mentioned there at the end, I mean, it didn't really come across in their video, but I mean, they are really helpful people who can give one-to-one advice on all kind of areas of starting up a new business, from marketing, finance, personnel, HR issues. And again, they deliver all that free of charge because they've got some grant aid behind them. So, I think between the two organisations, we can offer a lot of things to people in this space. So, if anybody's got any questions, then I'm willing to take them. So, do we have any questions? Don't be shy. Submit via the chat box or raise your hand, whatever it is. Not very familiar with this system, I'm afraid. Okay, so doesn't appear to be anything coming through. If anything does come to mind, please contact us. The website for the Energy House is energyhouse2, that's with the number 2.co.uk or .com, and that will take you through to our website. And there's a contact form there. Always happy to receive comments and questions from people. Have a look at the website if you're interested. There's probably a little bit more detail on there about what we're doing. And as I say, it's the way to contact us. We're here and ready to help you. Thank you very much for your time, and I hope you found it useful. Okay. few thanks coming through there, which is very nice. Thank you, Richard. Right, I think I'll declare it closed then. Nothing more coming through. Hope we hear from you again sometime. Thanks, bye.